This is 11-3, volume of pyramids and cones. So before we were doing prisms, now we're doing pyramids and cones. I want you to try the warm-up. Hit play when you're ready to see the answers. Okay, so for number 1, I got 3,969 feet cubed. For number 2, I have 14,964.9 meters cubed. And number 3, I have 1,408 pi inches cubed, or 4,423.4 inches cubed. These were all using V equals capital BH because they're prisms and cylinders, and they all have the same formula. Capital B meaning area of the base times the height. So if you take a prism and split it into thirds, you'd actually end up with the 3 pyramids that make up that same prism. So that's where the formula comes from for a prism. It's V equals 1/3 capital BH. So it's everything that we've been doing, except in the end you either multiply by 1/3 or divide by 3. It's the same thing. So looking at the first one, a rectangular pyramid with length 11 meters, width 18 meters, and height 23 meters. So V equals capital BH. It's rectangular, so it's going to be, oops, I already messed up. It's a pyramid, so it's 1/3 capital BH. Don't make that same mistake, please. So V equals 1/3 times the area of the base, which is base times height, because it's a rectangle, times the height of the figure. So V equals 1/3 times base times height is 11 times 18 times the height of the figure is 23. So 1/3 of that would be 66 times 23. 1,518 meters cubed. And square pyramid really would be the same thing, so it's V equals 1/3 capital BH because it's a pyramid. So V equals 1/3 times the area of a square, which is side squared, or base times height. So base edge length is 9, so it would be 9 times 9 times the height, which is 14. So V equals 27 times 14, basically, which is 378 centimeters cubed. 378, not 1,000. 378 centimeters cubed. Okay, here we have a pyramid as well, hexagonal pyramid. So it's a little bit more work because it's still 1/3 capital BH, but remember that the B is going to be 1/2 times the apothem times the perimeter. Regular hexagonal with a height equal to the apothem of the base. We need to add in more information here, so we'll say and a side length of 4 feet. So that means the perimeter is 24, since it would be 6 times 4. So we're still missing the apothem, and the height's going to be equal to the apothem, so we're waiting for that. We could call it A as well then, because it's going to be the same thing. Okay, so when we cut the triangle out of the hexagon, then it's going to be half the side length, so it's going to be 2. And the central angle, we need half of that, so it's a hexagon, so it's 360. Divide by the number of sides, 6, which is 60 degrees, but we take half that, divide by 2, we get 30 degrees. So that's 30, which means the apothem is 2 radical 3, and so is the height. So V equals 1/3, 1/2 times 2 radical 3 times 24 times the height of 2 radical 3. Remember when you multiply those radicals together, 2 radical 3 times 2 radical 3. Well, the radical 3 times radical 3 is just 3 times 2 times 2. So that part's 12. Half of 12 is 6. 1/3 of 6 is 2. So the volume is going to be 48. Let me just double check that. I had to cut down the length of this video, so I'll show you example 2 in class. Now for cones, remember it's the same thing. I just used the same formula, 1/3 capital BH. Just know that it has a circular base, so it's going to be pi r squared as the base. So V equals 1/3 capital BH. V equals 1/3 times pi r squared times h. So a cone with a radius of 7, so it's going to be 49. 1/3 times 49 pi times a height of 15. So V equals 245 pi centimeters cubed, or 769.7 centimeters. Okay, the next one, we have a cone with a base circumference of 25 pi. Well, that helps us because circumference is equal to 2 pi r, or pi d. So I know that the diameter is 25. So therefore the radius is 25 over 2, or 12.5. So that's good because we need that. So when we do our 1/3 capital BH, then we have 1/3 times pi r squared, so 12.5 squared, times the height, which it said is 2. Oh, 2 more than twice the radius. Oops. Times 2 more than twice the radius. Twice the radius was 25. So 2 plus 25, which is going to be 27. So V equals 1/3 times, let's see, let's write this out better. 1/3 times pi times 12.5 squared times 27. Calculate that, you'll get 1,406.3 pi inches cubed, or V is about 4,417.9 inches cubed. Okay, here we don't have the height. We have, we can use Pythagorean theorem to find the height. So that's what I'm going to start with. So a squared equals a squared plus b squared equals c squared. 34 is the hypotenuse, so I have 16 squared plus, we'll call it the height squared because we don't know what that is equal to 34 squared. So the height is equal to 30 centimeters if you calculate that. Let me double check. Yep, I got 900 when I subtracted that, and so square root is 30. So h is 30. Now I can go ahead and go through my problem. So when I find the volume, I get V equals 1/3 capital BH. Let me change the color here. It's too confusing with the other problem. So V equals 1/3 capital BH. V equals 1/3 times pi times radius squared, so 16 squared, which is 256, times the height, which we know is 30 now. So 1/3 pi r squared times 30. So V equals, once you calculate all that, we get V equals 2,560 pi centimeters cubed, or 8,042.5 centimeters cubed. Okay, the diameter and height of the cone are divided by 3, so that's like 1/3 if you divide something by 3. So if you take 1/3 to the third power, we can see the effects on it. So 1/3 to the third power is going to be 1/3 times 1/3 times 1/3, which is 1/27. So this is going to be 1/27 of the original volume. The volume will be 1/27 of the original, or divided by 27, however you want to say that. Okay, and then this one we have, looks like 2 cones and a cylinder. So for the 2 cones, are we saying the cones are the same? The cones are not the same? They're not the same. That doesn't make sense. They're definitely not the same. Okay, so because we have this is 35. So the height of this cone's 35 and the height of this cone was 40. So they're not the same. So I have two cones. I'll do those in one cylinder. The formula for the cones is V equals 1/3 capital BH because they come to a point, whereas the formula for a cylinder is V equals capital BH. So we have to be careful of that. Okay, so for the first cone, I'll call that a little 1 for the first one. This is my first one, the top one here. So let's do 1/3 pi r squared h, because that's what capital B is, pi r squared, which leads to 1/3 pi times 21 squared times 35 is the height. If you calculate that, you get 5145 pi centimeters cubed. Okay, and then you do the other one, we'll call it volume 2 of that other cone. So it's going to be the same formula, but the only difference is, or there are two differences? One difference, same radius. So it's 21 squared times, this time it's 40 instead. And that gets me 5,880 pi centimeters cubed. And then the other one is the capital BH for the cylinder, so it's going to be pi r squared, because it's still a circular base, times the height. No 1/3 this time. So it's going to be pi times, radius is 21, pi r squared, times the height of 35. And that is 15,435. And so when we add all of this up, big addition problem, we get that the volume equals 26,460 pi centimeters cubed. Or you can calculate that and you get 83,126.5, if we round it, centimeters cubed. So it's approximately. Whew, there it is.